And so now I would like to show you some slides and discuss in a little bit more detail the supernova explosions and the fabulous light output and the spin-up. So I have to make it quite dark. Make it completely dark. There we go. And so the first slide is simply an artist's conception, don't take this too seriously, of these beams of radio emission. This is then the rotating neutron star. And if the axis of rotation doesn't coincide with the magnetic dipole axis, and if you have these radio beams, which we do not understand how they are formed, then you can see when they rotate how they can sweep over you. Now you may say, well, that's a little bit artificial, because why would the axis of rotation be different from the magnetic dipole axis? Well, that is not an exception at all in astronomy. The Earth itself has a magnetic dipole axis which does not coincide with the axis of rotation. In fact, almost all the planets in our planetary system have a magnetic dipole axis which makes a large angle with the axis of rotation. So that's the rule in astronomy rather than the exception, even though it may not be easy to understand that. And these blue lines then represent magnetic field lines. You will see more of them than you like when you take 802. And here is Jocelyn Bell. Jocelyn Bell was a graduate student under Anthony Hewish in Cambridge, England, and she discovered pulsars. She found in the radio data, which were obtained using a new telescope that Anthony Hewish had built, she found in there periodic signals, pulses if you want to call them. You see some of them here at the bottom, and they were 1.3 seconds apart. And she reported that to Anthony, and Anthony said, well, that got to be nonsense, of course. I mean, there's not an object in the sky that is going to give us pulses with a separation of 1.3 seconds. So they just assumed that it was caused by an elevator, by maybe milking cow machines or things of that nature, motorcycles. And so they did every conceivable thing to check whether indeed this was a man-made phenomenon. But they could not find anything. And it was Jocelyn, through her incredible brilliance, who was able to convince Anthony that indeed this is an object that is in the sky and that the radiation doesn't come from the Earth. And when they realized that this would be the discovery of not only the century, but of all of mankind, because they said, well, who could possibly send radio beams at us and modulate them with a period of 1.3 seconds? Only intelligent life can do that. And so they called this first object Little Green Man. But just before they published, they discovered this in 1967, by the way, they found a second pulsar which had a slightly different frequency than the 1.3 second period. And so then they realized that it was probably not intelligent life, but that it was an astronomical object. So they gave that second object the name Little Green Man 2, but they abandoned that idea very quickly. Now comes the sad part of the story. In 1974, Anthony Hewish was awarded the Nobel Prize for this discovery. And Jocelyn, who more than deserved it, who really was the discoverer, who was the person who proved that this was astronomical, did not share in the Nobel Prize. It is upsetting. It is sad. I have discussed it with Jocelyn several times. I know her quite well. And she takes it actually very lightly. Too lightly, I think. Still people feel unhappy about it. And still, after so many years, the Nobel Prize was awarded in 1974, every time that I think about this magnificent discovery, and I think about Jocelyn, I think about this gross injustice. Here we see the Crab Nebula again. We've seen it before. The red filaments that you see here are the result of matter that was blown off when the implosion occurred and when the outer layers bounced off the inner core. And originally they had a speed of about 10,000 kilometers per second, and by now, it is about 1,000 years later, these speeds have been reduced somewhat. But here at the center, you see the pulsar, and last time I showed you convincing evidence that this is the pulsar because it's blinking at us. It has a diameter of about 7 light years. It is a distance from us of about 5,000 light years. In terms of angular size in the sky, it's about 5 arc-minutes in size, which is about 1/6 of the angular diameter of the moon. This is a drawing, a cave drawing, made by Navajo Indians, and some people have speculated to what extent the Navajo Indians may have seen the supernova in 1054. It's unclear, but it is a possibility. The moon certainly gets very close to the supernova, but it also gets very close to Venus, and so this is something that is not well established, but it is a possibility. Here you see a galaxy in which a supernova occurred, and when the supernova occurs at its brightest, it can be brighter than all 100 billion stars in the galaxy. That's how much energy is released in optical light. You see that it is at least as bright as the entire galaxy. From this picture to this picture is about 1 year. This occurred in 1972. And over the period of 1 year, you can still see this star quite clearly, but it has diminished in strength quite a bit. And then a great thing happened in February 1987. On the 23rd of February, a supernova went off in the Large Magellanic Clouds, which is a satellite galaxy to our own galaxy. It's a distance of about 150,000 light years. And there was an astronomer who was observing in South America. His name is Ian Sheldon. And he left the dome to look at the stars, and he decided to take a pee outside. And as he was taking a pee, these were his own words, he looked at the Large Magellanic Clouds and he said, "Hey, that is funny. That star is not supposed to be there." And he was the discoverer of what is now known as 1987A. An enormous supernova going off so close to where we live. And the next slide shows you the same portion of the Large Magellanic Clouds, and you can clearly see that there is a very bright star. He could see this with his naked eye. This is a picture made by the Hubble Space Telescope of supernova 1987A. The inner ring that you see is the result of matter that was thrown off by the star before it went into supernova explosion. Some 25,000 years earlier, it expelled gas in its equator. This is really a circle, although it looks like an ellipse because of the projection effect. And this ring of matter moved out with a speed of about 8 kilometers per second. And it has a radius of about 8 light months. And so 8 months after the supernova explosion, the ultraviolet light and the X-rays from the supernova caught up with this ring of matter, and they excited it, and it became visible. Before the supernova explosion, this ring was not visible. We are expecting in a few years that the matter itself that was thrown off with a much more modest speed of about 10,000 kilometers per second, that matter will also plow into this ring, and then we expect some real fireworks again. There is no explanation that people agree upon for these two called hourglass rings. They are quite mysterious, and there are papers written on it, and people disagree on their origin. Supernovae explosions in our galaxy and in the Large Magellanic Clouds are quite rare. We expect no more than about 1 in 100 years. The previous one that could be seen with naked eye was in the year 1604. It's called Kepler's supernova. And 1987A was really the first that could be studied with modern equipment, radio observatories, X-ray observatories in orbit around the Earth. With some luck, you may see a supernova explosion naked eye in your life, the chance is no better than 10%. So maybe it will help if occasionally you take a pee outside and you become as famous as Ian Sheldon did, who is now a very famous man. See you Monday.